Hey, what's up, man? And today we're gonna nail this hello viewers, welcome to this video. I'm Ryu from 9181C, and first, I'm going to tell you that this is a school project, so I obviously cannot be a hype beast, flexing, swearing, and beaming the whole time. However, this video is meant to be the introduction to some particular skills and knowledge, which is pretty important to VEX Robotics, and this time, PID control. So, instead of flexing like a crazy rich Asian movie, I'm going to go through a very general, easy, in a nutshell style tutorial about
the magic of PID control.
We will provide an overview of the use of PID controller algorithm in codes and VEX, a short explanation of the idea or the concept of the PID controller algorithm, deeper explaining on what P, I, and D controls are, and a guide to coding it, using it, and tweaking it in VEX Robotics Autonomous. So yeah, it is a complex task for me. I thought, how should I make this video interesting while I chew it down and explain some difficult calculus stuff that I am not even 100% sure about? And I just came up with this brilliant idea, which you are already seeing it on your big eyes. Yes, why don't I do it like a comic YouTuber? They do a really good job about telling their complex series of events they have experienced. Then why not I introduce their techniques to an introductive how-to tutorial? So here we go. Oh wait, actually, before we get started, I need to give credit on my group members, Jeff and Ethan, both from 9181J. Jeff is our smarter one, who actually wrote, described, and explained what PID is for this video. And Ethan, who supervised it and corrected it, because he was the only non-coder in our group. We wanted to make sure that even the person without any coding knowledge would understand the concept of PID. I only scripted it, read it, wrote sketches, and mashed them together into a video, so it wasn't too much of my work. I just brushed it up. So, thank you so much to both of my boys. Awesome work. And now, let's get into the topic. In order to have a nice tutorial, I prepared a table of contents for this video. We have 4 chapters to go through in the tutorial, consisting of Chapter 1. What does PID do? Chapter 2. What is PID anyways? Chapter 3. How does it work? What does each letter stand for? And Chapter 4. How can we use it? How do we code in VEX? You probably see the timestamps in the seek bar in the description. I know you would probably rewatch it a few times if you like this tutorial. So feel free to pause and move around to any point where you want to skip or rewind. Chapter 1. What does PID do? Let's start with the question. Have you had problems with the robot not going along a straight line? Or having different results every time going over or under your target distance with the same code? And having your program reduce your speed so that problem doesn't happen? I am pretty sure that all the beginner programmers are facing or has faced at least one of these problems when coding autonomous. But why? Well, there are a lot of reasons, actually. Whether it can be the different temperature of the motor generating different torques, the smoothness of the gearbox, other condition of the motor, wires causing losses of some electricity, VEX brain lags, different condition of the wheels, and more. Many of these issues are very hard to control with yourself. Furthermore, These can drastically change with the difference of the environment. Different fields, different temperature, new wheels, and lots of other things can be possibly involved. These problems are critical because it is so easy to affect the runs. So, in order to counter and minimize these problems, PID control is used to actively change and control the output value by software, so that results are more consistent. Chapter 2. What is PID anyways? What is it?
Is it a function to call out some super high-tech AI to automate the control over your robot? Or is it an online hacking tool for the supercoders to lively control your motor values?
No. It is actually a line of calculus math originally invented and used in engineering. I mean, that's still hella cool though, not gonna lie. In engineering, when the engineers design a control system, they use a loop to move the machines continuously. And at the end of each loop, the program gives back a running result. PID controls are widely used in the control systems by using these values to adjust in the inconsistent conditions. One of the easy, well-known examples of PID control is the cruise control on the cars. Conditions like whether the car is driving on an uphill or a downhill, wet or dry road, the traction on the wheels can cause differences in speed. The PID algorithm fixes the measured or current speed to the desired speed with the least delay and overshooting by controlling the output of the engine. Chapter 3. How does it work? What does each letter stand for? So, in the last chapter, I talked about how PID control is a calculus algorithm. There is more to it. The PID algorithm is a theoretical technique that applies to every system control. And PID, as its name, consists of 3 elements: proportional, integral, and derivative. Let's get deeper on each of them. Proportional control. I think it is better by first taking a look at the code without it. This is a typical one. Do you see a problem? Yes, this code sets the brake when the robot reached the target destination. This means that the duration of the deceleration is not considered, and therefore this code causes the robot to overshoot from the target destination. To solve this problem, the proportional control is introduced here. The P controller controls the speed smoothly, allowing the robot to slow down as it approaches its target. You can change the smoothness of your speed acceleration and deceleration by changing this value called Kp, which I will explain now. Take a look at this equation. This is what P control looks like in math equation. The T on the left is the torque, the power of the motor in this case. Kp is the multiplier. It is your only number in this P control that you can actually change. And torque equals the Kp times whatever this bracket gives out. This is actually pretty simple. The one on the left means the target value, and the one on the right is the current value. So, in other words, this equation is saying that the power of the motor should be the multiplier times the difference between the target value and your current value. This is why the P-controlled motors slow down when it approaches closer to the target, because the difference gets smaller. And your Kp determines how fast or accurate the torque is controlled in the P control. Sounds hard, but let's replace it with the numbers in this situation. Let's say that you want your motor to turn 180 degrees. You are currently at 90 degrees, and you assign your Kp to 1. What is the torque value? 90. Now let's say you changed your Kp to 2. What is the torque value now? 180. So, it is obvious that your Kp is going to determine the most part of how your motor acts in the PID control. Integral control. There are other issues left out if we are only using P control. Check this out. So, after starting to drive smoothly, there is some kind of error at the end when KP is a bit off. A constant amount of error will be left out at the end when the KP value is too low. This is because the P control gets too weak when it is close to the target. And when the KP is a bit high, it causes the torque to overshoot. Finally, when the KP is too high, now it causes the value to hunch, which means it goes back and forth the target. So here's where the eye control comes in. Eye control pushes or pulls the line back towards the target position when the constant error is there for a certain period of time. And Ki is, again, the tweaking part in this line of math. When Ki is smaller, it shortens the time required to trigger its correction, and therefore, it makes the correction faster. However, when it is too small, it causes the value to overshoot or hunch. So, you don't want it too small. Be careful when you set the value for the Ki. Derivative control, or some say differential, but I'll keep going with derivative. So, the PI control may already sound perfect, but there is a tiny bit left to fix. Remember that the eye control takes a certain time to trigger, right? This means that it is not good when there is a huge change in the output value. Something like a small bump on the floor can easily mess up because it reacts too slow to it. Same thing with overshooting and the hunching. So here is the D control to clean that up. D control will counter any larger changes by measuring the amount of error each loop compares the amount of error this time and last time, and changes the value correspondingly. Again, KD here is the tweaker knob in this math. KD is also like KI where you tweak the time. KD changes the amount of time for the D control to push the value back. When KD is larger, the effect of the D control gets stronger, and therefore it makes the response time quicker. However, when it is too large, it goes too much, causing to hunch. Haha, gotcha. Sorry, that was really bad. Sorry. So again, it is very important to have the right amount. So, combining all three, it becomes a PID control, which works like magic. So finally, we are now here to show our last chapter. How can we use it? How do we code in VEX? So now, I will show you how to make an PID controller in Prose in the easiest way. First, you want to implement the Prose Okapi library, Okapi chassis controller, and assign the values KP, KI, and KD for turning and going straight. These are the values I just explained in the last chapter, so check it out if you have no idea what those are. We separate these PID values for turning and going straight, because the torque required is pretty different, and it is better to have a different value for them to work better. Again, great thank you to our PID master, Jeff, for writing this code. Okay, so I guess that's it for this video. I will put the example code on the description in case you want to try it out right now. I hope you enjoyed this video and got an idea what PID control is. I am very glad if this helped you. Thanks for watching. If you are interested to these contents, make sure you subscribe, like, and hit that bell button to get the notification on your devices. And I will see you soon in the other videos on this channel. Bye!
So